All right, everyone. So, in example number 4, we want to look at simplifying the difference quotient for the following function. So, in this video, I'll do 3 examples. The first one is f of x equals 7. The second one is g of x equals 7x plus 2. And the third one is k of x equals 3x squared minus 6 plus 4. So here is the difference quotient. Here is the formula for it. The formula for it is given as f of x plus h minus f of x divided by h. Now, what is the purpose of this difference quotient? The difference quotient allows us to do 2 things. One, it allows us to compute average rate of change. And the second thing is that it allows us to compute the slope of a secant line. It's a fancy way of saying slope, but now for a secant line. A secant line is essentially a line that goes through a function at exactly 2 points, right? So I can just draw a quick visual just to have it out of the way. Let's say here's my y-axis being drawn again, and here's my x-axis, right? So let's say if I had some function, and that's how my function behaves. Let's call this function f, okay? Essentially, you can pick 2 points regarding this function. Let's call one of those values specifically x. So when I choose my value of x, you can find the corresponding y value by looking at the graph, right? Our value of x, our value of y would be this, and we can call it f of x, okay? So that's one of my points. Let's say if I choose some other value of x. Let's say I call it x plus h. Now, x plus h, that plus h would mean that you're some distance away from x, right? So let's say somewhere around here is x plus h, okay? If I plug x plus h into this function, you're going to hit the graph at that particular point. And essentially what I can draw now is a line that goes through this function. Oh, my bad. That line was terrible. You see, I like the other app because the other app I could play it off, not this one. So there you go. Here's my line. And that line is what we call a secant line. So the secant line, you can compute its slope, and its slope is given by the difference quotient. How do I know? Because when I plug in x plus h into my function, we can see where that order pair is located. That will be your f of x plus h, comma f of x plus h. That's 1 point. The second point is when you plug in x and you get f of x, some other output value. So the difference in the y values is precisely f of x plus h minus f of x, right? The difference in the y. And now it's all divided by h. Well, where did this h come from? Well, the h come from taking the difference in the x coordinates. If we start with x plus h, for example, minus x, right? Your x coordinates. What happens to your x's in that expression? If I have x plus h followed by minus x, what would happen to my x's? Yeah, the variable of the x would cancel out, and what are you left with? You're going to left with the h. So essentially, this formula allows us to compute the slope of a secant line, and there's also other real-life applications, finding average rate of change. One common example of that is average velocity, okay? I just want to point what it looks like visually. All right, now back to our functions. We have 3 functions here. You should be able to know at least the type of function. For example, if the first function is f of x equals 7, do anybody know what type of function this is? It's a linear function with a slope of it's a linear function, but a specific one. Say it louder. 0. You see, it's a linear function with a slope of 0. We call it a constant function. no matter what value of x I plug in, the output value is always going to spit out 7. So if I plug in 1, I plug in 4. What's your name? Tori? If I plug in Tori, it spits out 7, right? So we have a constant function here. What about our second function? No, what's the name? What type of function that is? G of x equals 7x plus 2. It's a linear function. We know that graph is a line. And in this, for this linear equation, for this linear function, you know its slope, right? Our slope is 7, right? So for the constant function, we have a slope of 0. For the linear function, you have a slope of 7. All right, and now k of x is 3x squared minus 6x plus 4. What type of function that is? This is going to be a quadratic. Now, with quadratic functions, what does its graph look like? We haven't talked about quadratics yet, but you will soon in your classes. What shape is that? Yeah, what shape is it? What? It's a U shape. You can say smiley face or sad face, right? Quadratic functions look like this. It looks like a smiley face without the eyes, or a sad face without the eyes. All right. And with quadratic functions, can you identify the slope? No, it doesn't give you the value of m. Okay. All right. So I just wanted to do that quick review. Let's actually now solve all of these problems. So for our first function, it was defined as f of x equals 7, right? So if I want to apply my difference quotient, the very first thing that I always like to do is compute f of x plus h. That's always my step 1, right? So step 1, compute f of x plus h. For this example, it's pretty easy. I erased something. I meant to write something else, and I wrote back what I erased. There we go. All right, so for f of x plus h, this example is quite easy because look at your function. Do you have an x there? Do you have a variable x in the constant function? No. Every time that I plug in a value of x, what does it spit out? 7. So if I plug in x plus h, it spits out 7. Very good. So that's your step 1. Step 1, done. Compute f of x plus h. It was already done for us. It's a constant. So step 2 now is where you do the whole difference quotient. Rewrite the difference quotient. Okay, so the difference quotient was given as f of x plus h minus f of x. So here's what I like to do. This example is quite straightforward based on the values I give you. But in general, what I like to do is keep the f of x plus h and the f of x term separated using a bracket. So I'm going to put a bracket around the f of x plus h term, which is 7, minus the original function, which was also 7, all divided by h. Good things happen for you because if you look at the numerator, whatever you have in common between the two brackets, since there's a minus sign separating them, then the terms can cancel out, right? So in this example, both of the brackets contain a 7. 7 minus itself is 0. So you'll get 0 over h. Now, what is 0 over h? As long as h is not equal to 0, so I should write one more comment. As long as h is not equal to 0, we say that the solution here is 0. And you're done. Step 1, this problem is completed. Let's look at a second example where I do something with a linear function. Let's say now I have g of x is equal to, I don't know, let's try to figure this one out. What was the example I gave you? Oh, 7x plus 2. Sorry, is this the noise outside? Gets me distracted nowadays. Getting old. All right, so step number 1, you want to compute now g of x plus h. If I compute g of x plus h, then that means that wherever I see an x, I'm going to replace it with x plus h. Now look at your function. How many times does x appear? Once, so you replace that x with x plus h. So this will give us 7 times x plus h plus 2. Now you can expand the g of x plus h. How do I expand this? I will distribute the 7 inside the parentheses. So this will give me 7x plus 7h plus 2. That's all for step 1. Now we do step 2. Step 2 is like the long step. I do everything in that particular step. As you can see in the previous example, we are going to rewrite the difference quotient. Followed by simplify. All right. So here's how this goes. So in the numerator of your difference quotient, you should have g of x plus h minus g of x. But just remember, I like to keep these things separated using brackets. So the g of x plus h terms, I'm going to put it in its own bracket, 7x plus 7h plus 2, minus the original function, which is 7x plus 2, all divided by an h. Good things happen for us when you use this bracket, because now you can see that you have some more terms here. Since your g of x plus h terms is separated from the g of x terms with that minus sign, then whatever they have in common, you can cancel it out. So what terms can I cancel out? 7x can go bye-bye. What else? The 2's. Right? So all the terms of the original function is going to be wiped out, essentially, when you do the subtraction in the numerator. Right? I'll repeat myself. All the terms of the original function is going to get wiped out. The only terms that's going to be remaining are terms that will contain an h. In this example, there was only one term that contained an h in the numerator, and that was 7h. So as long as the h is not equal to 0, what happens when you do 7h over h? The h's will cancel. And what are you left with? You're left with 7. Now, there was a whole reason why I talked about these functions. In the first example that we did, f of x equals 7, we knew that it was a constant function. And what is the slope of this constant function? You look back into your notes. What did we say the slope of a constant function is? 0. Well, look at the difference quotient. What did we get? We get it 0. Look at the second function. G of x equals 7x plus 2 was our linear equation, or linear function. What was the slope of that function? 7. What is your answer for the difference quotient? 7. Do you see the correlation? It all comes back to what I did in that picture. Essentially, if you have a constant function or a linear function, the slope of the secant line, or the average rate of change, is going to be precisely the slope. So if you ever had to do the difference quotient for a linear function, you can always clearly figure out that, okay, whatever my slope is, that's going to be the answer. I just have to show it. How do I show it? It's exactly what we did in the first 2 examples. Now, can we make this argument for non-linear functions, linear functions? And the answer is no, right? If you have a quadratic, you're no longer going to say that this, whatever the slope is, you can't even find the slope you can't even identify the slope of a quadratic function, but you're going to get a family, essentially, okay? So let's look at the third example. It was h of x now, or sorry, k of x. K of x is equal to 3x squared minus 6x plus 4. So what is my step number 1? Can somebody tell me what's my first step? That's right. So you said f, but it's actually k. Well, he said f, you said k. It's actually k because that's the name of our function this time, right? So we have to compute our k of x plus h, okay? So look at your function now for this quadratic. How many times does the variable x appear? It appears twice. So I need to replace x with x plus h twice. So this will give us 3 times x plus h squared minus 6 times x plus h plus 4. Okay? Now I'll show you how I expand this. First of all, if I have x plus h squared, that means that I got to do x plus h times x plus h. The remaining terms, I'm just going to rewrite it as I go. Oh, sorry. Yeah, I know. I think it's the, my bad. It's not you guys. It's the Wi-Fi. Let me share content. Yeah, sorry about that. It happened to me last meeting too. It's the Wi-Fi in this room. I don't know why it does that. All right, we're back in action. I would say, imagine if all my work just now got wiped out. I've been so mad. Okay. All right. So we expanded. So x plus h squared, you can rewrite it as a product of x plus h times itself. This allows me to do the foiling technique. So the way that foiling works is the following. We're going to have 3 open parentheses, x times x. That will be x squared. Then we do x times h, which is xh. Then we do h times x, but h times x is the same thing as x times h. And then you do h times h, which is h squared, minus 6 times x plus h plus 4. Then lastly, I combine any like terms. So if you look at inside the bigger parentheses, you have 2 copies of x plus h. If you combined it, that's going to be 2xh plus h squared minus 6 times x plus h plus 4. All right, now in my final line of expanding this out, I am going to distribute the 3, and then I'm going to distribute the negative 6 inside of the parentheses. So if I distribute the 3 inside the parentheses, this will give us 3x squared plus 6xh plus 3h squared minus 6x minus 6h plus 4. Whew. Now, here's the shortcut of this. Do you remember back in elementary school when you've done like writing or spelling a word 5 times or 10 times on the paper? You guys remember that? If you do the x plus h squared part like 5 or 10 times on paper, like x plus h squared, then do x plus h times x plus h, then FOIL, then combine like terms. You'll eventually memorize that x plus h squared is x squared plus 2xh plus h squared. Okay. Okay. So here you go. We have our k of x plus h. Now we apply the difference quotient. So the difference quotient, like now you can see, since we have a lot more terms going on, you put them around brackets. So we put first the k of x plus k of x plus h terms in brackets. That is 3x squared plus 6xh plus 3h squared minus 6x minus 6h plus 4 minus the original function, which is 3x squared minus 6x plus 4, all divided by h. So whatever terms that the 2 brackets have in common, you can get rid of. What terms do they have in common? 3x squares, what else? Negative 6x, what else? And the fourths. So if you notice, the terms of the original function for k of x, it was defined as 3x squared minus 6x plus 4, The terms of the original function is now wiped out. What you're going to have remaining are the terms that only can involve an h. So you have 6xh plus 3h squared minus 6h all divided by h. Now, as mentioned, because all the terms in the numerator contains an h, you can factor one of it out from the numerator. So this will give us if I factor the h out from the numerator, this will give us h times 6x plus 3h minus 6 all divided by an h. As long as h is not equal to 0, these h's, the h that I factor out and the h on the bottom, they'll cancel out, and your answer will be 6x plus 3h minus 6. And that's your answer.